Hello, my name is Wes Furman. I'm the LSIC lead at the Johns Hopkins Applied Physics Laboratory. Reduced gravity is one of the first environmental differences that people think of when they conjure images of astronauts on the moon, and it has significant implications for technologies and activities on the lunar surface. The moon's gravity varies across its surface, but is about 1.62 meters per second squared, or roughly 1/6 of Earth's gravity. This inhomogeneous gravity field can complicate achieving stable orbits, especially for the very low orbits that could be possible given the lack of an atmosphere, and additional fuel is required for active orbital corrections. The reduced lunar gravity also has obvious effects on weight and motion. The behavior of objects under lunar gravity is unfamiliar and can make manipulation and control during operations more difficult. Luckily enough, a few humans have been to the moon and experienced this reduced gravity firsthand. Apollo astronauts have likened walking in the moon's reduced gravity to walking on a trampoline, without the springiness and instability. Jumping around to a target area may seem like a fun experience, but walking, standing after falling, and performing normal science and exploration tasks were incredibly difficult and exhausting for the astronauts.
Rat.
This difficulty must be considered in mission objectives and the technologies to support the limitations of human capability on the moon. Reduced gravity on the lunar surface also alters how moving components interact with the lunar regolith. Because of the reduced gravity, a loaded wheel can have a higher velocity than would be expected on terrestrial soil, leading to sinkage and reduced function, with less reaction force available for activities like excavation. For example, this image shows stainless steel wheels moving horizontally on the lunar regolith. A regolith velocity that's higher and more variable than that on Earth can lead to increased likelihood of soil failure, limited bearing capacity, and wheel sinkage. As such, hardware for rovers and other systems interacting with the regolith needs to account for reduced gravity effects and its impact on performance. In addition to this altered reaction force, other mechanical limitations should be considered by engineering design, such as center of mass and tilted surface stability. Reduced gravity also alters fluid and particle dynamics. Systems that are particularly dependent on proper design and engineering for reduced gravity include heat pipes, propellant tanks and hardware, and water purification and recovery systems. Some novel manufacturing opportunities may even be enabled by reduced gravity, such as the growth of large silicon wafers for electronic materials. Several aspects of crystal growth that lead to defects are altered in reduced gravity, and growth size is limited terrestrially by weight. Manufacturing processes on the moon could also take advantage of the strong vacuum. There are also physiological effects imposed by the reduced gravity. Remember those videos on how much exertion is demanded from the astronauts to perform activities on the moon? Well, not only is the environment different and unfamiliar, it also affects muscles, bodily fluids, and neurological response. An entire body of active research is dedicated to this field, which can inform the lunar technology community on astronaut safety needs for this environment. There are several options for testing for reduced and microgravity. Short-duration tests can be done by drop towers, such as the NASA Zero-G Research Facility at NASA Glenn Research Center, which is capable of testing up to 1,000 pounds. Parabolic flights are another short-time option, along with rocket-powered vehicles such as New Shepard, under development by Blue Origin. For longer tests, consider the use of gravity offload rigs to suspend and tilt hardware in an effort to mimic the reduced gravity environment. Alternatively, orbital missions can be used for in-space qualification, and nothing is more high fidelity than an actual lunar mission, which can be accessed with the help of NASA programs like the Commercial Lunar Payload Services and other flight opportunities. Thank you for watching. I hope this module has been informative.